Well, have a good day. See you tomorrow, day one.
Okay, no one talked again. Quiet. So talk, Ari.
24 start.
Okay, no problem. No. Listen. In calculus, I'm serious, in calculus you get used to that, okay? I refer to my job a lot, but I'm dead honest when I say there were a lot of projects when they handed it to me, I'm like, I don't know where to start either. So it's a part of learning how to get past that. First thing is we've got to have enough flashcard facts in your head that will prevent you from getting stuck. So when I read the problem, facts need to flow to your mind, and then they need to be written down. For each function shown, identify values for A and B. So I stop right there. So what does that tell you, Ari? Like so far, like don't worry about the whole problem. Just tell me what you know so far. That's it. The goal. No, really. I know that doesn't seem like a lot, but you're heading in the right direction. You understand that the goal is to find A and B. Awesome. That will make the function continuous. So tell me what that tells you.
That there won't be any jumps or discontinuities.
Or what's the third one you got to worry about?
Vertical.
Perfect. You're doing just fine. You're just getting frustrated, which is normal. Okay, it just is normal in this class. So hang in there, you're fine. So we know that, look, we can't have a removable, can't have a jump, can't have a vertical asymptote. Somebody help her build on that. Like on those facts, what else should come to mind? Because what happens, Ari, is you think of those things and it gets you to think of other things. And Brooklyn.
Well, I mean, you told us one time that if it's a piecewise function, then you should look at the points where it changes functions because those could be possible.
Smart. With the piecewise function, if the piecewise is going to have a discontinuity, the formula that you see here could have a removable or a vertical asymptote anywhere. But these can't. Why not? Somebody help. Why am I just ignoring the fact that these could have a removable or a Miranda, please?
Well, the vertical, it has to be a fraction, and so you automatically can roll that out there.
And the other, I didn't mean to interrupt you. Sorry, I just think something I hadn't really explained very well. Perfect. This one cannot have a vertical asymptote. I am done with that part of it. So 2 out of 3 now, just 2 left. It can't have one type of removable either, because you'd have to have 0 over 0. So I don't have to worry about that either. So now I'm back to what Brooklyn said. All I have to worry about is what's happening near x equal 2 and x equal 4. That's it. That's all I have to worry about. Good there? Okay, the last thing you really need to be remembering is this. Everyone must have memorized what is required to make a function continuous, because the only place I'm worried is x equal 2 or x equal 4. What is required? Somebody raise your hand and tell me. What's required to make a function continuous at x equal 2 or x equal 4? What's the memorized fact that you must know?
The left limit has to equal the value of the function and the right limit.
Perfect. It's my 3-finger thing again. Perfect. Yes. It's my 3-finger thing, okay? The limit from the left must equal the value of the function, which must equal the limit from the right. So, good, no, yes? You sure? Okay. So now I just do that. I say, let's go find it. So, Ari, what's the limit as x approaches? The key numbers are 2 and 4. So go 2 from the left of this function called f.
Or even the top one, so a little less than 2 plus 1 would be close to 3, so squared is close to 9.
So that limit's 9. Good there? Just keep going. So now I check this one.
More than 2 is
Either way, I was going to do F of 2 next, but either way, what's F of 2?
F of 2 is
Is what? Oh, close. Plugging in close to 2 here is going to give close to 4, but then we add a.
Oh.
So if it doesn't become 4 times a, 4 plus a. Okay, point of advice for everybody. You're awesome, just keep switching back, it's totally fun. But just hey, Mikkel, so good to see you. Come sit with me this 1 minute. So good to see you. You have no idea. No, really, you have no idea. So good to see you.
He's really good at
No, you guys don't know. They're okay. I'm serious. No, really. There are some students like you work with so much. Like your sister's like that. She is. Like,
She talks about you all the time.
like really. Okay, sorry. Turn on. Okay. Sorry, I lost all track of reality. Shoot, concentrate. The big key I wanted to tell you was this. You have to change your mindset from I solve a problem by knowing the steps to I solve a problem by just kind of fighting my way through it. And eventually it becomes clear. Like Brooklyn's the best. She's like, oh, I see it now. Like, and you can tell, right? You can just feel it. This is like that. You're not supposed to necessarily know steps. You're supposed to think of connections like you did. And as you tick off the connections, eventually something happens. So what happens here? Did you figure anything out yet? Well, we don't want one to happen. Remember, we're trying to make the function be continuous. So what have we discovered? A needs to be 5.
They're all 9.
So they're all 9. So that makes this function continuous at 2. Does that make sense? You okay on time?
Yeah.
All right. Making sure.
Take your
All
time.
right.
Wait, wouldn't A equal 5? Not 2.
Oh, Mikkel's distracting me. So. What would you do now?
Do the same thing before.
Do the same thing at 4, yeah. Good work. I'm going to talk to Mikkel for just a minute. So.